Okay, this is my screencast video 3. It was about a second order linear homogeneous differential equation with a constant coefficient. So right here, I have the equation. Um, it's second order because of the the double like y prime, and then it goes down to double to single and to a regular, not even prime. It's homogeneous because dx is equal to 0, and it's constant coefficient because all these letters in front of it. So yeah, in order to solve these, we have to have a characteristic equation. So I decided to make it m squared plus am plus b that equals to 0. And then case 1, and then when you have it like that, to m squared plus am plus b, you could like solve it by using the quadratic formula. But in this first case, you don't really need that. It's not that hard. So in case 1, when roots are real, uh, when roots are real in the solution of equation 1, it's going to equal yx equals c1 e to the m1x plus c2 e to the m2x. So here's our equation: y prime plus 6y plus 8y equals 0. We plug that into the characteristic equation. We get m squared plus 6m plus 8 equals 0. We factor that easy. We get m1 equals -4, m2 equals -2. Those are real. And then we plug that into the formula. So yx equals c1 e to -4x plus c2 e to the negative. That should be an x. I don't know why I didn't write it, but yes. So in case 2, when roots of the characteristic equation are same and real, the general solution of the equation is yx equals to c1 e to the mx plus c2x e to the mx. Here's our regular second order: y prime plus 8 prime plus 16y equals 0. And we're going to plug that into the characteristic to solve for it. This one doesn't need the quadratic formula. It's not that hard. So we get m squared plus 8m plus 16 equals 0. Then we solve that. So we get m plus 4 squared equals 0. And then we take the the m's, and then it's going to m equals -4, and then another -4. So that right there shows that we have the same roots and same solutions. Well, it's same roots and real. I don't know why I said solution. I was reading solution when I read real. But yeah, so now we're going to plug it in. Y to the x equals c1 plus c2x. And I decided just like to factor out the e to the -4x, but it's exactly the same thing. The -4 goes right there, and we're good. So those two were pretty simple. They weren't hard. Um, we didn't need to use quadratic. So now we're going to have one that we do need to use quadratic. So when roots are imaginary, m1 equals ai plus I, m1 equals alpha I plus I beta, and then m2 equals a minus I beta. The general solution will be y x equals e to the alpha x parentheses c1 cosine beta x plus c2 sine beta x. And then here's our solution: y prime minus y prime, y double prime minus y prime plus 5y equals 0. Um, Here's our characteristic: m squared minus m plus 5 equals 0. We're going to plug that into the quadratic because it doesn't factor out that easy. M equals plus 1 plus or minus square root of 1 minus 5 times 1 divided by 1. And then equals plus 1 plus or minus the square root of -4 divided by 2. You can't have the square root of a negative number. So that's why it's imaginary. Then it's going to be equals plus 1 plus or minus I square root of 4/2. I know you could like simple this down, but I didn't want to. It makes it, at the end of the day, it's the same thing, and it just looks better to me, I guess. So right here, we're going to get m1, and that equals 1 plus the square root of 4i divided by 2. Then we're going to get m2 equals 1 minus the square root of 4i divided by 2. We're going to get our alpha, that's equals to 1/2, and then our beta is equal to square root of 4 over 2. And then now we're going to plug it in. So y of x equals e to the x over half, parentheses c1 cosine of square root of 4 over 2 of x plus c2 sine square root of 4 over 2x. So that's how you solve second orders that are homogeneous. You just basically have to have the characteristic equation. So you could solve like at like worst, like you have to use the quadratic every time. But sometimes it's as easy as just factoring it out. Then you get your roots and then you plug them in into your the general solution of the case that you have. So yep, that's my screencast video 3. To be honest, it wasn't, I wouldn't say it was terribly difficult. It was pretty easy to understand. It's pretty like straightforward of like how you solve it. Man, thank you.